Welcome to Automated GUI Testing using froglogic Squish. My name is Amanda Burma and I'll be conducting the webinar today. Today we'll be going over Squish for Windows. Froglogic is headquartered in Hamburg, Germany and has presence in the US. We were also established in 2003 and we have a large and growing customer base throughout the world. You can see some of the more than 3,000 companies currently using Squish as well. Now, while today we'll be focusing on testing Squish for Windows, it's important to understand that Squish works with a variety of technologies, all at the toolkit level. So, meaning we work with each of the objects, we see and understand the objects for each technology that we support. And those also work across the different platforms on which those technologies work. For example, Qt or Java might go across your Linux, your Windows, and your Mac boxes. Web, the same thing. So whether it's an embedded environment, a desktop environment, mobile device, etc., we support a variety of technologies and platforms. Now, Squish offers record and playback functionality as well as powerful scripting, so you'll have the combination of both, as well as access to your GUI toolkit, so access to your application's API. And whether your application is made up of more than one technology or a single technology, we can support hybrid technologies as well. When you're executing tests, you can execute tests from our IDE, using our command line interface, using also a variety of integrations that we offer. So you have those options, and you'll see some of the distributed testing today simply demonstrating from our command line interface. And a bit of a unique thing about us, we share our source code with customers. Now, as far as test creation goes, the inner left box represents your Squish IDE. That's where you will generate most of your test scripts. The IDE triggers the Squish runner and the Squish server, communicating then with the application under test, or AUT, by injecting a hook, allowing it to understand the application, see its objects, its object properties, and then interact with the application as an end user would. Now, much like test creation, your test execution can be with the IDE or often from an unmanned environment, such as something scheduled either using our command line interface or one of our integrations. Using again our test scripts, which are very portable, having Squish runner then connect over the network either locally or to one or more Squish servers, which are listening and then will execute the tests and report back the results. As I mentioned earlier, we do provide a variety of integrations, and here are some of the integrations that we provide. And for the complete list, see the list on our website. So just a few slides, and now we'll begin with the actual demonstration. So today I'm going to work with the Squish for Windows IDE. The IDE looks the same no matter which technology you're testing, but it's all about the technology you're testing and your technology's API and how we have access to those objects. Now, I am recording this at a different resolution than the typical resolution, so you'll notice things can be a little crowded at times, but know that when you're working on this from your own environment, it will look much more spacious. So now, if we wanted to come up and instead of using this existing test suite that I have here, create a new test suite, we'll simply click File, New Test Suite, and I'll enter in a name, call it Delete. Click Next, and this is where I can select my primary toolkit. So today we'll be focusing on Squish for Windows. So we'll work with the Windows toolkit, and that means a native Windows application. Here we can then select also which scripting language we'd like to work with. I'll stick with JavaScript for today. And what application we'd like to test. We can either select from an application we may have already mapped from another test suite, or we can browse and select the application that we would like to test. This then becoming our primary application to test, but not the only application that you can test using your test suite. Now, because I indicated that as my primary application to test, now from my test suite, I don't have any test cases, so that'll be the first thing we do. We'll create a new test case, simply click record, and we can see my application launches. Close this window here. We can also see from the control bar that I'm recording. And from the control bar, not only does it indicate that I'm recording or what actions I'm performing, a bit as a status, we can also create verification points, whether we want to verify an object and its properties, verify a screenshot, setting a threshold for error, or masking items that we perhaps in the screenshot don't want to focus on or only want to focus on, as well as a table-based verification point to verify a table and its contents. And at any point you can also add a comment within your script so that when you return to your script, you'll see the comment when you were at that point in the recording. So now if I simply interact with the application, clicking File New, for example, Edit Add, any of these actions, say I add my phone number in, and then after a set of actions, oftentimes you then want to validate what it is that your test was trying to exercise. Not only was it exercising the functionality, you want to validate the expected result. And that's where we'll come back to our control bar. This is something we can do during our initial recording, or by recording a snippet by inserting additional recorded steps later on once our recording's already created. So I'll click here. That returns me back to Squish, where I can browse my application object tree, see objects and properties. But first, let's use our object picker to select the object that we're interested in verifying. So I'll select my last name here, for example, in this field. Now I can see not only that object, but I can scroll up in the object tree to see parent objects, and I can see all the properties of these objects. Now, one of the things that we'll be going over today is the difference between how Squish has extensive object-level access to objects and properties compared to some other tools, such as tools driven using MSAA or Microsoft Accessibility Access, where the same or extensive properties may not be available. Here you can see we have our basic properties as well as access to the native object. You have access to your complete application's API. Any property of an application, of your objects, is available. And some of those objects, if you're using MSAA or limited to that, may not be available to you. So you may be restricting your ability to test, or, as we'll see later, you may not be getting the full story or the complete value, only the value that an end user might see from the surface. So I created some steps, I created a verification point. Let's click stop and see what we recorded. So here I can see my verification points down below in this test.compare. I have my entire script that I recorded, the application that I started. I'm clicking on various items, and again, due to my resolution, things can be a little crowded at times here. And then here we can see the different objects I'm interacting with, and then you'll notice these wait for object or wait for object item statements. Now those statements tell Squish to take a look at the object, make sure it can find the object. If it can find the object, is the object visible and is the object enabled? Because we want to make sure the object is in a state in which we should interact with that object before proceeding. In the event it's not ready, there's a default timeout, which is 20,000 milliseconds or 20 seconds. If you don't specify this parameter, which it's not specified by default, it goes to the 20,000 milliseconds. But you can modify that parameter at any time to any other duration to increase or decrease the wait. However, 9 times out of 10, that's not required. It might be required, for example, if you were generating a large report and had a significant amount of information to pull, requiring your application to take longer. But in that case, incorporating other logic, such as a try-catch or try-except statement, might be more applicable. You have the entire power, you have the power of the entire scripting language that you're using. So in this case, I'm using JavaScript. Anything JavaScript can do, I can do within here. I'm using Python, same thing, Perl, TCL, Ruby, etc. Now, how are we finding those objects again? Here we see an object's symbolic name. So that's this first thing in quotes here. That symbolic name is also in our object map. So I'll open the symbolic name and see the object in my object map. Now in my object map, I can see not only the symbolic name, but I can also see the real name of that object. So this real name is the collection of properties used to correctly and uniquely identify that object. If, for example, the application changes, something changes, a property changes within one of your application objects, you can come to the object map, make the change in a single location, and not have to find the location where you used it in every single one of your scripts, saving a great deal of maintenance time. Now, you also have the ability to, here you can see this is set to a constant, equals. As I name my address book a different name, this object's text changes. So if I want to accommodate that, I may want to use a wildcard or a regular expression to work with my object, instead of using a constant. By simply changing it to wildcard, changing this to an asterisk, and saving my object map, I now have made a change so that without changing the symbolic name, which I have the option to do if I'd like, I can now go back to my test. I haven't made a single change to my test, but once I name my address book to anything else, that primary window, when that window changes, as long as it matches the wildcard expression that I've indicated, everything will still pass. Now here we can go through and we can see the other actions that I took, typing in the various fields, clicking OK, and comparing this particular cell, making sure it has the string Burma. Now as I run this script, when your scripts run, and they run quite fast over GoToMeeting, so you can miss little bits at times, but we'll run it a few times, you'll get your test results. And with your test results, you'll see what passed or failed. Now in the event you encounter an error or a failure, you can have a screenshot automatically captured at that point in time. And there's also a flag for when you're working from the IDE to indicate if I can't find an object, and it pops up an object not found window, which helps you troubleshoot and correct either the object map entry or whatever it is that is causing the script not to be able to find the object. It's a nice troubleshooting tool. So in order to do that, if I were to change one of these objects so that, for example, instead of being equal to OK, now I changed this in an earlier demo to cancel. So we'll see if that's still set to cancel. Here we have our OK button. Now, if instead of OK, I change this to yes, let's say, and I try to run this script. So we'll back out of my object map. I haven't changed my script. But let's say that my OK button, it doesn't have the properties it needs to be able to find that object. We'll see now what happens when I execute this. So now it's looking for that OK button. And remember, it's looking for the OK button, and it has that wait for object. So it's going to give it some time to see if it actually does appear. And then, when it can't find that object, that's where I do have a setting set in my IDE so that if I'm working from my IDE, it automatically pops up here to tell me, okay, well, from the IDE, here's the old value. Well, let's go out and see what object that is. I can either throw an error and it will return the error in my results. I can debug the script and go to my script debugging. Or I can click retry and see if maybe it's ready now. The other thing I can do is go out and select that object that I know that step is trying to find and see if there are any differences between the value in my object map, which remember I purposely changed, and the new value. It highlights those differences, and now if I click retry, it will click OK, and it will be able to continue the script. So it helps you troubleshoot when you're not able to find an object, or for errors when you're not quite sure why it's occurring. Now other things that I might do, for example, let's say that, let's go to another test here. I'm going to go to a different test suite. Let's say that I have this long linear script here, right? And in this script, I want to stop at a certain point because, I forgot to record a certain step. So I can click to add a breakpoint at any point in my script, run my script to that point, and then after that executes, I can either use that breakpoint to troubleshoot my script. For example, I might be back here and I might not be able to find an object, or I might not know how I want to proceed. Maybe I want to know if this object is actually going to be available when I get to this step. So I have this script console where I can send commands to the application and see what the result is. So it returned it was able to find that object. Could it not find the object, it would sit there for the 20 seconds and then return the object not found error. Other things you can do here is, if you're working with a regular expression or some logic, or working with building, instead of using a symbolic name, you're dynamically building a real name at runtime. You want to make sure that works. This console will let you send commands to the application, and it will send back the response just as it would as if it were executing a step in your test. Now, if I had variables in my script, they would appear off to the left here. And from my breakpoint, I have the ability to spy objects and see their properties. All of the methods available, again, to my particular application's API are available to modify in my script so that I can refactor my script, improve my script. And much as I did when I was creating my verification point, I can go out and spy objects here from a breakpoint, or simply if I had clicked Launch AUT without a script running. All at which times you can then interact with your object map and your application objects. I also have the ability to step through each step in my script, or in this case, let's do this. Let's right-click and select Record Snippet. And then here, I can, let's say I want to, delete a few of these, oops, and then add a different number. Or however I want to enhance my script, I want to add some steps. You want to make sure you don't break your script in adding steps, as, this is a sequential script here. And then once I hit stop from my debugger, I can see my test and the new steps I added. So you can see I clicked on that field twice, and I typed backspace. So the different steps that I clicked on, what I entered in. And then it will execute those if I wanted it to as well. So now here with my breakpoint, I can remove my breakpoint and rerun my script, and everything will still run. Now this is a linear script, it's not all that exciting. What if we wanted to refactor our script to have more information in it, become data-driven? By right-clicking on a highlighted portion of script, you can select Make Code Data-Driven, and that's going to help you create a script very similar to this one, where you can have a data array, for example, and you can iterate through your script. And instead of having this all in one script and iterating through with a larger for loop, this has been extracted to the add name and addresses function, where you can see then the for loop that would otherwise exist in the main function. And here I'm calling another function, invoke menu item. And then I'm going through and adding items for each element in my array. And then in invoke menu, you can see an example of how I'm dynamically building an object's real name at runtime, so that no matter what menu I click on in menu item, I can pass that information in as a parameter and reuse this. Now I could run this script here, and I have these functions that are still local to my test case. But what if those functions are something I want to use throughout my entire test suite multiple times? I want to save time by really refactoring things for reuse. Well, that's where I can create a test suite resource. And in my test suite resource, I can define a number of different functions. For example, this is Python, so we have our different definitions here. And then I can call each of those definitions simply from a test script by indicating and telling Squish, hey, look in my scripts, either in my global scripts for my test suite resources for this file. And from there, or it will also look as a test case resource for additional scripts. And then from there, I'm going to iterate through, and this time instead of using a data array, I'm going to use an external data source. For example, I have here a TSV file, a tab-separated file, with a lot of data in it, for my address book. Now, instead of a tab-separated file, maybe you want to use a CSV, a spreadsheet, a database connection, etc. Many different data types you can use. But the idea is you can iterate through and refactor this test. Now, I do have a break in here so that you don't have to watch it through every single one of those data entries from my spreadsheet, but it'll iterate through, and then it's also using my external scripts. If I set a breakpoint at any point here too, we'll be able to see what happens when you have variables in your script and how you can view all the different values of those variables, much as you do when you're spying an object. But this really helps when you're stepping through a script. You want to see the values. We collected all the values of a table, so we can see that through here. Now, what are some of these objects that you might not be able to see if you were working with a more complex object? Maybe an object that has an internal status as well as a status that exposes to the user. So what might I want to do in that case? Let's go over, and I have a very similar application. Close those tests. Which, if I set, let's set a breakpoint right here. I'm going to run to this line, and there is a status bar in this application. You'll notice very similar, it just has an import bar. And this status bar, while it's processing some information, is not revealing to the end user exactly the value, how far along it is in the process. But it is along a certain way in the process. Now, if I were to use Squish and spy this object, even though the user can't see what that is, Squish, because it is indeed a property of that object, can see what that object is, all of its values, minimum, maximum. Remember, you have your native object here, so all sorts of things. And then we have our value. Well, we can see that the value of that status bar is actually 32. So it's not 0, it's not 100, it's not 70, it's actually 32. Whereas that's not available to the user. And there's a number of different types of objects where you may want some information that's behind the scenes that will help drive your script or help give you some type of confirmation that this test was a success that may not be visible to the user. So we can see that information. Now, if we stop this and go take a look at if we were working with that same application. So let me open up that application again. If we were working with that same application, but instead of using Squish, we were using an application, a testing application that relied on MSAA and not simply on, let me get my address book back here. There it is. And not simply on the way Squish relies. So Squish inspects the objects, can see the objects, it understands each toolkit, and it can see all the values of the different objects. Now, if I come over here, and I'm having a little trouble with my resolution because I'm a little confined for space here. If I come over here and I click import, and then we see this import status bar object, right? Remember, from Squish, even though the end user couldn't see it, we were still able to see its actual value. But using Microsoft Accessibility Access, you can see the accessibility access, because it's supposed to reveal something for someone with disabilities, for example, read aloud what a user can see. Well, that's what it's reading, the 0% value. It doesn't know what that value is because an end user looking at it doesn't know. But we behind the scenes in Squish, because of how well we can see and work with objects, we're able to see that value. So that's just one simple example of one way you could be limited if you only test using a tool that works with Microsoft Accessibility Access versus Squish, which is able to see so many different objects and properties of those objects, as well as interact with custom objects and derive support for even objects that you may have created on your own, not derived from standard objects. Now if we come and take a look back here, the other thing I wanted to show you was executing from the command line interface. So while typically the Squish server is going to run when you're in an unmanned situation, you know, you're running these post-build or using one of our integrations, that Squish server is going to be on another remote system. So you're going to trigger that to run. For this particular case, I'm going to run it here locally. So we're going to run Squish server simply by calling it from the command line. Again, this is similar to how you might use it from an integration too. And then what we're going to do is also use our command line interface, and I've set up some variables here indicating where Squish is located, where I want to generate a report, the test suite that I want to execute, where the Squish server resides, so you can see by simply changing this to another destination where a server is listening on this Squish server port, we could then execute the test there. And then this simple Python mapping is so I can convert my generated report in XML to HTML. Many different report option outputs as well, all listed in our documentation. So you can see here I'm calling Squish runner. This is a bit cleaner to look at since I used the variables. And I'm specifying the host, the port, the test suite I want to run, and to generate a report. So if we run this, and close that, I'm going to start Squish server, minimize that. And then what I'm going to do is I'm going to run this script here as it would if you were running, let's say you scheduled this batch file to run, or you scheduled an integration to run using our command line interface or one of our integrations. You can now see here that it's executing the test without the IDE. Now how easy is that for me to then simply change what IP address I'm pointing it to, have a Squish server listening on another system, and run this. That's how easy it is to distribute. These tests are very portable. They're simply a flat file. Check them into a source control. You can look at your changes, your history, and diff changes over time with your tests. So you're able to look at those. It is in the scripting language that you've selected. So now this test runs. It's running the entire test suite instead of an individual script because that's what I indicated. And then after it's done running, it will generate the report. Now it's generating the report in XML, and then it will, using that script that I called, convert it to HTML. And here we can see the one I just ran. You can see I have failures and passes. And if we want to see details, we can see my summary. And the more logging information, the more naming conventions you use, the more you include in your script for logging and the naming conventions, the more this will tell you. And also, again, if you encounter an error, you have the ability to have it automatically take a screenshot, and then that link would appear here in your test to see not only the information you're logging regarding a verification point or an error, but also a screenshot to give you a visual when that occurred. So coming back to our slides here, just to reiterate, remember how we work with objects really will help the robustness and how well you can test your application and how many objects you can interact with, that information that you have available. We have an intelligent, agile object map, extensive integrations with different build, ALM, and CI tools, and then our recording and playback combined with access to your application's API, the Squish API, as well as one of many scripting languages, actual non-proprietary scripting languages that you can select to use to create and run your test framework. Please download and evaluate at froglogic.com evaluate, a 30-day evaluation, and also take a look at our resources at froglogic.com resources for additional information during your evaluation. You can contact us at squish@froglogic.com, sales@froglogic.com, or by going to our website and submitting the evaluation form. I'll stand by for any questions, and thank you for attending today.